And now the Coulomb's law of relative permittivity and dielectric constant. So the relative permittivity we can define. We all know that the force between the two charge. The charge is suppose Q1 and Q2. There are two charge. They are r distance apart, and we have already established the relationship. The force between two charge in any medium is given by 1 upon 4 pi epsilon naught q1 q2 by r square, and in case of air it is given by this expression. This is equation number 1, this is equation number 2, and now if we divide equation number 2 divided by equation number 1, then we get equation number 2, that is 1 upon 4 pi epsilon naught into q1 q2 upon r square divided by 1 upon 4 pi epsilon naught epsilon r into q1 q2 by r square. This one and this one, these are cancel out, epsilon naught. So here Fa is equal to Fm. So what is the value of Fa is equal to Fm? All these are cancelled out, and the only thing remain here is epsilon r, which comes into the numerator. So this become Fa by Fm is equal to epsilon r. So from here we can easily find out what is the relative permittivity, what is the relationship between the relative permittivity and the force between the medium and the air, between the two charges. So this is a very important expression, and so many questions you can solve with the help of this equation. So just remember this equation. Now the next is the dielectric constant of the medium. What is the dielectric constant? What is the value of dielectric constant? Basically dielectric constant and dielectric constant K and relative permittivity are same. We can easily prove from here. We know that in CGS system Fm is already we have proved this in this expression 1 upon k q1 q2 upon r square, and in air it can be written as, because in air the value of k is equal to 1, so this expression is reduced to this one, Fa is equal to q1 q2 upon r square. When we divide 2 by 1 we get k is equal to Fa upon Fm, and we all know that epsilon naught r is equal to also Fa upon Fm. So from this one, from this equation and from this equation, it can be concluded that the proposed dielectric constant is equal to the relative permittivity of the medium between the two charge. Relative permittivity. So this expression is also very important. Just remember this thing. Now the value of dielectric constant for some medium, you can see here, the more the value of dielectric constant, the lesser is the force. And here you can see in water the value of dielectric constant is 80, and for vacuum and air almost same, that is 1, and in the rest of the thing you can see here. So from this table we can find out that if the two charge, if they are placed, if two charge q1 and q2 and they are placed in a medium air, then you can see the value dielectric constant is the value of k is equal to 1. So here in air the value is 1 upon 1 into q1 q2 upon r square, and in case of suppose both charges q1 and q2 are placed in a water, it is a medium water, then what is the value of force between these two charge? So we can write like this: Fm is equal to 1 upon 80 into Q1 Q2 upon R square. So from these two equations you can easily find out that the force in a medium in a water is 80 times reduced, because dielectric constant is 80 times more than the dielectric constant of vacuum or free space. So the more the dielectric constant, the lesser the force between the two charges. As you can see here, Fm is equal to 1 upon dielectric constant Q1 Q2 upon R square, and you can see Fm is inversely proportional to the dielectric constant. So yes, there are some questions for you student, and these are the questions. Just note it down and try to solve these questions. It is a very simple question which is based on whatever we have studied in this lecture. Try to solve this question. It is a very simple question and you can easily find out the solution. These are theoretical questions. In the next video lecture I will give some more advanced question which are based on the Coulomb's law and electric field and all these things. So thank you, and I will post a new lecture series also, because from here we will start in the next video. I will explain electric field and the vector form of Coulomb's law, vector form, and then we will discuss on electric field. So thank you.